your vocab packet. We are ready to talk about an experiment. Do you guys want me to let you write for a few minutes and then talk about all of this?
Yes, please.
Okay. Sitting back and watching an experiment, you were actually controlling some things. So an experiment is just a controlled study. You're trying to measure something, so you are going to take your explanatory variables and see what effect that has on a response. So I will change my explanatory and look at the response. Okay, my explanatory variable, think like this year versus last year. So last year the feedback I got was they hated the textbook. So what explanatory variable am I trying to change this year? Yeah, I'm trying to use the textbook less and make worksheets and things to try to eliminate that and see if it has an impact on the response, which is the feedback I get on the homework. You know, last year they said, I just don't even know what the question's asking, so I'm trying to eliminate that problem. So my factor, or my explanatory variable that I'm changing, is the type of assignment. And I'm measuring the response. How well do you guys understand the material from that? So the experimental units, or the subjects, again, we kind of touched on this before. Those are the people. Who would be the experimental units in my experiment here? You guys, right? I'm trying to see how you do with what I'm teaching. So you are my subjects. The control group serves as a baseline that can be used to compare to other treatments. Do I have a control group in this case? No. Really all I'm doing is 2 different types of homework and seeing which one works better. A control group, in a lot of cases, like if you're thinking about medical studies, the control group would be if they're trying to test a new medication, the control group gets no medication, or they get a placebo, something that is just like a sugar pill. It doesn't really do anything. And they're seeing, is there a difference in the actual medication versus just this placebo? So the control group is just like your baseline that you're measuring them against. All right, is that okay? So let's go ahead. 2 more. So in those types of medical scenarios where they have, you know, a placebo versus the real medication, there are differences. We can do a single blind or a double blind. You know, if I say, Eli, I'm going to give you a sugar pill, then he knows it's not going to do anything to help him, right? So do you want to actually tell somebody you're giving them nothing? No. So if you know what you give them, but they don't, that's a single blind person. Only one person doesn't know. But maybe I want to know, maybe I think I might treat Eli different if I know he's not getting any real medication, so I don't want to know which one he's getting either. So if the researcher and the subject both don't know which one they're getting, that's double blind. 2 people don't know. Let's look at an example. Go to your example packet. Alright, so the English department of the community college is considering adopting an online version of the freshman English course. To compare the new online course to the traditional course, a faculty member randomly splits a section of her course. Half the students receive the traditional, and the other half is given an online version. At the end of the semester, both groups will be given a test to determine which performed better. So this is kind of like the type of question I would ask you. I'm going to give you a scenario and just kind of ask you these things. So not really saying what is the definition of an experimental unit, but can you tell me what that is by looking at the problem? So who are the experimental units in this case?
The students.
The students. Okay, you could be more specific. You could say the freshman English students, but it's just those people that we are concerned with there. All right, what is the population that we are worried about?
The English department.
Yeah, we want to know, the group we're looking at is basically the students in that one particular course, the one professor's course. So if you wanted to make this more specific, you could add that in. we're concerned with everybody. She's not the only one that might go online. We're looking at all of our English students. What would be the best option for them? So the entire population is the freshman English students at this college. The treatments.
Online and traditional.
There are several ways I could ask that. I could call it treatments. I could say the explanatory variable. Another word is the factor. That's just the thing you change. So response, what are we trying to measure here?
Which system?
Yeah, which group is going to do better? So, and we're specifically looking at that particular test. So you could say their grade, you could say their test performance, who does better in the class, any of those things would be fine. Okay, could I do a single or double blind experiment here?
Single.
So if it's single blind, that means you don't know which class you're in. If it's double blind, that means I as the teacher and you as the student, neither one of us knows which class you're in. Is that possible? No, you're going to know if you're going to campus and sitting in class or if you're pulling out your laptop and working at home. Okay, there is no way to prevent you from knowing which class you're in. So blinding is not possible here. So there are some steps to designing an experiment, and I don't think I printed this for you. This is not, I'm not going to say on test list the 6 steps to designing an experiment, or, you know, A, what is this, B, what is this. But this is just kind of in general the things that we are going to look at as we're going through this class. So we have to have a problem to be solved, okay? If I don't have a problem, then I have no reason to design an experiment. If I want to see what makes you learn better in this class, that is my problem to be solved. 2, determine the factors that affect the response. Okay, so if I want you to do better in this class, the factors. What things can I control that would impact the outcome, how you do in this class? 3, determine the number of experimental units. How many people are we looking at here? 4, we haven't talked about a whole lot. Determine the level of each factor, controlled versus randomized. That is not something that I'm going to really spend time on. But basically, we're looking at the factors being the things you manipulate. Can you control them or not? You know, can I control if I'm using the book or not? Yes. Can I control if you know how to read? No. So that would be something that I would have to consider, but I can't really change that in here. Then we have to do our experiment, and then basically the first half of this class, we're talking about that first part, and then we will get into inferential statistics, which is looking at our data and figuring out what that tells us at the end. What conclusions can I draw from what I found out? So back to our term, we're just going to look at a few more types of experiments. So we talked about what a single blind experiment would be and a double blind experiment. Completely randomized is when everybody is randomly assigned a treatment. You walk in this classroom and I have you roll a dice. And if you roll an even, you have to do all of your homework out of the book. And if you roll an odd, I will give you a worksheet for every section. it's totally random which one you get. Let's go ahead and just finish all of our definitions while we're here. In matched pairs, it's a design when the experimental units are paired up. And they have to be paired so that they are somehow related. So that means I wouldn't necessarily want to compare, just take two of you and compare your test scores. But maybe I do chapter 1, I make worksheets for everything. Chapter 2, I do book assignments for everything. And then to compare, I take for each of you your test score on chapter 1 and your test score on chapter 2. I'm comparing you to you. It's matched pairs data, it's your scores both times, but there were different factors in that. So a lot of times this would be like a before and after. If I'm trying to see if a new exercise program is good for weight loss, then I might take your weight before you do the exercise program and your weight after and compare those two numbers. So your data is paired up. It doesn't have to be the same person. Maybe we're going to do a husband and wife take the same survey and we compare their answer. Okay, that data, that pair makes sense. They're married, so they have something in common, and we're going to compare their responses. So does everyone understand what matched pairs is? Blank stare. Does that mean no, or does that mean nobody wants to answer? You understand? The last two terms we have here. In blocking, we group together similar subjects and then randomly assign them a treatment. I'll let you write these notes. So in blocking, I take all my subjects and I assign you to groups somehow. So maybe it's, I take all the students in the math department and I group them together in freshman, sophomore, junior, senior. Or I group them together in Mrs. Keller's students, Mrs. Dyer's students, and my students. So we have a block. Then we do different treatments with each. So it may be that Mrs. Keller's students are going to learn by playing games, and Mrs. Dyer's students are going to learn by watching videos, and my students are going to learn by reading a textbook. And we're going to compare them. Okay, I could randomly assign that. So I might say, okay, here are my 3 groups, here's my 3 treatments, and I'm just going to draw a number out of a hat to see which of the 3 treatments you get. That's randomized block, if I randomly assign who gets what from those groups. So let's look at some examples of these different types of experiments. So an engineer wants to know whether the level of octane in gasoline affects the gas mileage of an automobile. Let's design some kind of experiment. How could we make an experiment that would tell us this? So, first of all, let's kind of run through my list of things that I need to know. You know, the first thing, we have to identify a problem to solve. What am I trying to solve?
If octane affects the gas mileage.
Okay, does octane level affect gas mileage? That's what I'm trying to solve. All right, so then we need to figure out what factors would affect the response variables. So what things do I have to consider?
The octane level.
It's different octane levels there are. I don't know, I'm no expert on gasoline, but there are different octane levels, right? So we could compare those. Then we would need to decide, you know, how many cars do I need to look at? Is there a difference in one car versus another car? So we wouldn't just want to take 3 different cars and put them out there. We would need enough to actually get a good sample. So then, what would our actual experiment look like? What could we do?
Get 3 of the exact same car, like exact same model, and one has like high octane, one has low, and then one has medium.
Okay, so we take 3 of the same car. Does driver have a difference in it? Probably. Are you one of those people that rides your brakes all the time? Are you one of those people that, you know, gradually accelerate, or do you just slam the pedal down and go as fast as you can? Those things affect your gas mileage, don't they? So if I really want to control all of that,
Same driver.
you could do the same driver. Could I even use the same car? Yeah, so does where you drive have an impact? Yeah, if you're driving in town versus in the country, if you're doing hills versus a flat road. So these are all things that we would need to take into account if we were going to design a good experiment. So maybe a good experiment would be, okay, I got a car, and I am going to fill my gas tank full with this octane level, and I'm going to go drive this road until it's empty. And I'm going to see how many miles I can go until it's empty. And then I can do that again with a second octane level and a third octane level. And so that would be a good experiment there. So we're not really designing experiments yet, but these are some of the questions that we need to be thinking of. What about this one? Xylitol has proven effective in preventing dental cavities when included in food or gum. A total of 75 Peruvian children were given milk with and without xylitol and were asked to evaluate the taste of each. Researchers measured the children's ratings of the 2 types of milk. All right, what's the response variable? What am I measuring? The taste of the milk. Okay, think of some factors. What are factors? Yeah, the factors, that's just another word for the explanatory variable, the thing you're manipulating. So some factors to consider is the milk with or without xylitol. Okay, that's the factor that we're controlling, the main thing. We're going to give you 2 cups of milk, one has it, one doesn't. Are there any factors like that might affect this that I haven't considered?
Depending on the kids are lactose intolerant.
Okay, is the kid lactose intolerant or not? Do they like milk or not? What about age? My 1-year-old is a lot more likely to drink what I hand her than my 11-year-old, right? My 11-year-old's like, this looks funny. This smells funny. There's a speck of dirt in my cup. I'm not drinking that. Okay, so would age have an impact on it? Absolutely. So there are lots of other things. So maybe just jot down one more. We mentioned a couple. I'll just do age. Okay. So which of these are we manipulating? Yeah, the one we're actually controlling is the xylitol, but that doesn't mean that's the only factor. There are others. Okay, the treatment. The treatment is just another word for the factor we manipulate. So that is the milk with or without xylitol. How many treatments are there? 2. The milk has it or it doesn't. which type of experiment is this? I'm gonna have, it's a designed experiment, and I'm gonna have the same child drink both cups of milk and compare their responses. That's matched pairs. I'm not comparing Kaylin's response to Riley's response. I'm having Kaylin drink both and see which one she likes better, and then have Riley drink both and see which one she likes better. So this is matched pairs. What would be my experimental units here? Yeah, the 75 Peruvian children. Okay, why would it be a good idea to randomly assign which one you drink first? Instead of having every child first drink the plain milk and then drink the milk with it. So there's not a bias there. Is it possible that you're really, really thirsty, so whichever one you drink first is going to taste better to you just because you were so hot and thirsty? Yeah, probably. Now, if you're really hot, you don't care as much about what you're drinking. So it's just a way of eliminating some bias. Okay, do you think it would be good to double blind this experiment? So what does double blind mean? Nobody knows which one you're drinking. Why would that be good? Right. You know, I'm thinking, I'm doing this experiment to try to prove that xylitol doesn't affect the taste, so we should put it in every kid's milk because it'll be better for their teeth. And so if I give Bo 2 cups of milk and he tastes one, he's like, I don't think I like this. I'm like, come on, Bo, it's the same milk. Doesn't it taste good to you? And this ice cold milk just for you. Could I say some things to kind of sway his opinion? Absolutely. So what would be best? That nobody knows, so you don't have any bias in there, so you don't sway the kid's opinion. So it helps with that sampling error, trying to get a certain response out of somebody. One more. So let's go back to that English department scenario where we were talking about online versus regular English. So after some deliberation, the English department thinks that there may be a difference between the men and the women. So what could I do? If I think that women are going to be better at English no matter which class they're in, or maybe men are going to be better no matter which class they're in. Or maybe I think men will be better online and women will be better in person. How can I help with this? What could I do to take that into account?
Take their populations of the men and women and divide them in half to online population.
Instead of just having you walk in and number off 1, 2, 1, 2, okay, the ones stay here, the 2s go home and learn on your Chromebook, I could say, okay, I have 20 women, so I'm going to put 10 women in each group. And I have 30 men, so I'm going to put 15 men in each group. What would that be if I break them into groups like that first? Which type of experiment is that? Well, we're getting our sample like that in terms of sampling. That would be like your stratified sample. In terms of the experiment, that's like our blocking experiment when we break them into groups. So let's just say assign equal numbers. so a couple things I want to talk about. There is a handout posted on Classroom. It is pretty short over just this section. Tomorrow, because we are at the end of chapter 1, I would like to do a chapter 1 quiz before we move into the second chapter. So let's talk about that a little bit, all right? It is not a very long quiz, and remember, quizzes are worth like 2% more than homework in here, so it's not a massive part of your grade. The first thing we talked about was qualitative versus quantitative. What was qualitative? Alright, if I ask for hair color, that's qualitative. It's just a quality characteristic. Quantitative is numerical. So if I said height, weight, number of siblings, that's quantitative. You won't have to come up with these terms. The directions will say, identify this variable as qualitative or quantitative. Okay? Make sure you're paying attention while I'm running through this. You will have a minute here just to look at your homework, but I just want to make sure we know what's on it. With these quantitative ones, we can break it into discrete and continuous. If I'm talking about number of siblings, that would be discrete. If I said your height, that would be continuous. Basically, if decimals are allowed, it's probably continuous. Then we'll do level of measurement. I'll probably run through some examples of those at the beginning of class tomorrow. Again, you're not going to have to come up with the terms. I will give them to you. Nominal, ordinal, interval, ratio. Then we got parameter versus statistic. Remember, a parameter deals with the whole population. A statistic deals with the sample. And then it'll be the different types of sampling. So, simple random, systematic, stratified, cluster, convenience. And like I said, we'll do a few examples of these things tomorrow. All of these terms, it will just say in the question. It'll be like, 3-part A, B, and C, identify which of these, pick from the list. I'll do a types of bias. So the response, non-response, and sampling bias. And then one question that's going to be kind of like tonight's homework. So I give you an experiment and I ask you just tell me what are the factors? What's the response variable? Who are the subjects? Those kinds of things. So pretty much the whole quiz is one-word answers. Pick from this list, tell me which one it